They say the universe begins at the center of light. And in our solar system, that light blazes from the sun, a massive ball of plasma that fuels every planet in its orbit. But right next to this searing giant is a planet so close, so intensely baked by solar radiation, that it lives in a constant battle with fire and ice. This is Mercury, the closest planet to the sun, and yet one of the most misunderstood. It's a world of extremes, of ancient scars and silent mysteries. And in this two-part journey, we'll explore every detail of this elusive world. So let's begin where space truly starts, just 58 million kilometers from our star. Mercury orbits the sun at a blistering pace, completing a full lap in just 88 Earth days. That makes its year shorter than a season on Earth. From the surface of Mercury, the sun doesn't just rise and set, it dances. In some parts of the planet, the sun appears to rise, then reverse, then rise again. This bizarre optical illusion is caused by the planet's unusual orbital speed and rotation. Mercury spins very slowly, just once every 59 Earth days, which means it experiences long days and longer nights. One day on Mercury, from sunrise to the next sunrise, lasts 176 Earth days. But don't let its small size fool you. Mercury is only slightly larger than our moon, yet it has a metallic core that spans nearly 85% of its diameter. That core is mostly made of iron, making Mercury the second densest planet in our solar system, right behind Earth. This iron heart generates a weak magnetic field, about 1% the strength of Earth's, but still powerful enough to interact with the solar wind and create magnetic storms. Temperatures on Mercury are another extreme. You might think that being so close to the sun would make Mercury the hottest planet, but that title actually belongs to Venus. Why? Because Venus has a thick atmosphere that traps heat. Mercury, on the other hand, has almost no atmosphere to speak of. That means it can't retain heat. During the day, surface temperatures soar to 430 degrees Celsius, 800 degrees Fahrenheit, hot enough to melt lead. But at night, with no atmosphere to hold the warmth, temperatures plunge to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. Mercury is a planet of boiling days and freezing nights. The surface of Mercury is ancient and scarred, a reflection of its violent past. Craters, cliffs, and impact basins stretch across its face, some dating back nearly 4 billion years. One of the most famous features is the Caloris Basin, a giant impact crater over 1,500 kilometers wide. When whatever celestial object struck Mercury to form Caloris hit, it sent shock waves rippling around the entire planet. On the opposite side of Mercury, scientists found strange, jumbled terrain, almost as if the planet shuddered and cracked in response. But the surprises don't end there. Mercury also has enormous cliffs, known as scarps, that stretch for hundreds of kilometers and rise as high as a mile. These cliffs are believed to be the result of the planet shrinking as it cooled. Yes, Mercury is literally shrinking. Over the past few billion years, its core has contracted, causing the crust to fold and crack. It's like an old apple wrinkling as it dries. Despite being the closest planet to the sun, Mercury is also one of the hardest to study. For centuries, astronomers could only observe it during twilight, when it peaked above the horizon just before sunrise or after sunset. Early observations were limited, and Mercury remained a blurry, flickering mystery. That began to change in 1974 when NASA's Mariner 10 became the first spacecraft to visit Mercury. It mapped about 45% of the surface and revealed the rugged, cratered world beneath the haze. Decades later, NASA returned with the Messenger mission. Launched in 2004, Messenger, Mercury surface, space environment, geochemistry, and ranging, orbited Mercury more than 4,000 times between 2011 and 2015. It completed the job Mariner started, mapping the entire planet, studying its magnetic field, and analyzing its composition. Thanks to Messenger, we discovered that Mercury contains water ice in its permanently shadowed craters at the poles. That's right, ice on the closest planet to the sun. How is that possible? At Mercury's poles, deep inside craters that never see sunlight, temperatures remain cold enough to preserve water ice for billions of years. This ice likely came from comets or was released from inside the planet. It's one of the many paradoxes Mercury offers, a fiery world that hides frozen secrets. Messenger also found evidence of volcanic activity. Ancient lava plains cover large areas of the planet, indicating that Mercury was once geologically active. And now, as we enter the modern era, Europe and Japan have teamed up on a new mission, Bepi-Colombo. Launched in 2018, Bepi-Colombo is currently en route to Mercury, with arrival expected in 2025. This ambitious mission includes 2 orbiters, one focused on the planet's surface and geology, the other on its magnetic field. Bepi Colombo will build on Messenger's legacy, helping us unlock the next level of Mercury's mysteries. Mercury challenges our understanding of planetary formation. Why does it have such a large core? Why is it still geologically active? And how did it retain water ice? These are questions scientists are eager to answer. Because the more we learn about Mercury, the more we understand about the formation of rocky planets, including Earth. Mercury acts as a time capsule, preserving clues from the early solar system. But Mercury isn't just a scientific puzzle, it's also a symbol of endurance. Imagine a world that exists in the furnace of the solar system, constantly bombarded by solar radiation, micrometeorites and extreme temperature shifts, yet it survives. It spins, it shrinks, it holds ice in its shadows, and it dances with the sun in a cosmic waltz unlike any other. Mercury reminds us that beauty doesn't always lie in comfort. Sometimes it's found in the struggle to exist. Great. Let's continue with part 2 of your 3,000-word YouTube script on the closest planet to the Sun. Focusing now on Mercury's exosphere, space-weather interactions, mysterious anomalies, mythological symbolism, and its relevance for future space exploration. This continuation maintains the same engaging tone, natural flow, short paragraphs, and integrates LSI keywords like Mercury exosphere, solar wind interaction, Mercury gravity anomalies, space missions to Mercury, and asterisk Mercury and mythology. Mercury has no atmosphere in the traditional sense. Instead, it has what's called an exosphere. This extremely thin layer of gases isn't enough to support weather, clouds, or even breathable air. In fact, if you stood on Mercury, you wouldn't feel any wind, see any movement in the sky, or notice any atmosphere at all. But that doesn't mean nothing is happening above the surface. Mercury's exosphere is constantly replenished by solar wind, micrometeorite impacts, and the slow release of volatile substances from its crust. This exosphere contains elements like hydrogen, helium, oxygen, sodium, potassium, and even calcium. They drift like ghosts around the planet, forming a faint, shimmering aura detectable only by sensitive instruments. One of the strangest sights observed by spacecraft is Mercury's sodium tail, a long, comet-like stream of sodium particles trailing the planet, pushed away by the sun's radiation pressure. This tail stretches for millions of kilometers into space, giving Mercury an eerie resemblance to a comet. But Mercury's interaction with the solar wind is where things get truly fascinating. Despite its weak magnetic field, Mercury is the only rocky planet other than Earth to have one. This means it has a magnetosphere, a protective bubble that interacts with the constant stream of charged particles from the sun. When the solar wind slams into Mercury, it compresses the magnetosphere on the sunward side and stretches it out into a long tail behind the planet. Within this magnetic field, strange phenomena occur, including magnetic reconnection, where magnetic field lines snap and release bursts of energy. Messenger recorded frequent magnetic storms on Mercury, short-lived but intense events that blasted the surface with particles. These interactions help scientists understand space weather, not just around Mercury but across the entire solar system. Studying how Mercury copes with the sun's fury helps us model how other planets, and even future spacecraft, might fare under similar conditions. Then there are the gravity anomalies. As Messenger orbited Mercury, it made precise measurements of the planet's gravity field. What it found was unexpected, uneven distributions of mass beneath the surface, suggesting hidden structures or varying densities. Some areas seem to pull more strongly than others, hinting at possible underground volcanic features, denser rock formations, or remnants of ancient impacts. These anomalies are like buried fingerprints from Mercury's past, waiting to be interpreted. Another mystery is Mercury's hollows, strange, shallow depressions scattered across the surface. They're unlike any features seen on other planets. Bright and irregular in shape, these hollows appear to be relatively young and might form when volatile elements in Mercury's crust vaporize, leaving behind empty spaces. But exactly how they form and why they exist only on Mercury remains a puzzle. These hollows give scientists insight into Mercury's unique geology and its composition. But Mercury is not just a scientific enigma, it also carries mythological weight. The Romans named the planet after Mercury, the swift-footed messenger of the gods. In mythology, Mercury was known for his speed, cunning, and ability to travel between realms, just like the planet itself, which races around the sun faster than any other. The ancient Greeks called it Hermes. To early civilizations, Mercury's brief appearances in the sky before sunrise or after sunset made it a mysterious traveler between light and dark, a celestial courier dashing between the realms of day and night. These mythological roots are fitting. In many ways, Mercury is a messenger, not of the gods but of the early solar system. Its heavily cratered surface, oversized iron core, and ancient geology tell a story that dates back over 4.5 billion years. By studying Mercury, scientists uncover clues about the violent birth of the solar system, the formation of rocky planets, and the processes that shaped Earth itself. In a cosmic sense, Mercury delivers messages from the past. Now, what about the future? Could Mercury ever be a destination for humans? On the surface, it seems unlikely. The extreme temperatures, radiation, and lack of atmosphere make it one of the most hostile places in the solar system. A human colony on Mercury would need to be built underground or shielded inside massive protective structures. Yet, the planet does offer certain advantages. Its low gravity, about 38% of Earth's, could make launching spacecraft easier. Its proximity to the Sun also makes it a perfect location for solar power experiments. More realistically, Mercury could serve as a stepping stone for robotic exploration. Just as we test technologies in Antarctica or underwater on Earth, Mercury might be the proving ground for missions designed to survive the harshest environments. If we can build machines that operate on Mercury, we can build them to operate almost anywhere, including on Venus, Mars, or even the moons of Jupiter and Saturn. BepiColombo, the joint mission from the European Space Agency and JAXA, is a major step forward in this effort. Once it enters Mercury's orbit in 2025, it will provide more data than ever before. From measuring the planet's magnetic field with high precision to mapping every crater, fault, and ridge in unprecedented detail, BepiColombo promises to transform our understanding of this small, elusive world. It might also help answer long-standing questions about Mercury's origin. Did it once have a thicker crust that was stripped away by a massive collision? Is its enormous iron core a clue to planetary evolution gone wrong, or something else entirely? Ultimately, Mercury represents a paradox. It's the closest planet to the Sun, yet it hides ice. It's the smallest rocky planet, yet it has the largest core-to-size ratio. It seems lifeless, but it's geologically active. It's a world of opposites: fire and ice, light and shadow, silence and storms. And it's precisely these contradictions that make Mercury so important to study. Because in understanding Mercury, we don't just uncover its secrets. We gain insight into how planets work, how they form, and possibly even how life might emerge elsewhere. So, the next time you see that tiny dot near the horizon during twilight, know that you're not just looking at a planet. You're looking at a survivor, a messenger, a mystery that's traveled billions of years through space and time to tell its story. And that story, Mercury's story, is far from over.